All right, so today we're going to warm up, well, we're going to start talking about inverse trig functions. And you've done this before where you've had to use the inverse trig functions when you were solving for an angle, like either whether it's through law of sines and cosines or doing a right triangle trig problem. And you just kind of magically get an answer from your calculator, and that's what you write down. But today we're going to investigate like why your calculator is giving you that value. And then we're going to dive a little further into that and realize that there actually are several values your calculator could give you, so we have to talk about why it's only giving you the one value. All right, so let's talk about this. There's a big difference. Whoops, this is a lot to look at. There's a big difference between some of the things that are written up here on my board. This first one being sine of 30 degrees. Now, if you were in degree mode and you typed sine of 30, that's you applying the sine function to 30 degrees. But remember, the unit circle is something that you can just reference for this question. You're going to get a value, which is on the unit circle. By the way, looking at your unit circle, what is the sine at 30 degrees? It is 1/2. So that has to do with the way the function looks when you graph it. However, this next question, this next statement, says 0.5 equals sine of theta. So in this case, if you think like an algebra student, you'd ask yourself, okay, well, how do I solve for theta? Because that's the variable in this equation. Well, you would apply the inverse sign, right? That's what you would have done on your calculator. And again, your calculator, if it was in degree mode, would have given you 30 degrees as an answer. These are saying the same thing, they're just written very differently. Here's what's happening. Today we're going to be working with inverse functions. So we're going to be looking at statements that look a lot like this and also like this today. These two statements mean the same thing. Inverse sine is also known as arcsine. So inverse cosine, also known as arccosine, and then same thing with tangent. So you have to kind of get in your brain that those are synonymous with each other. As we look through some of these today, I'm going to write down like different ways of saying the same thing. Kind of bring it back to an algebra equation so it makes more sense. All right, unfortunately, first thing you have to do is suffer through a little graphing with me. There we go. So think back to what you guys know about functions and inverse functions. If we graph the sine function, and I'm calling it a sine function because it passes the vertical line test, I might be able to ask you something about his inverse, which we don't see a picture of inverse sine until you look over here. But up until today, we didn't see a picture of inverse sine yet. But if I asked you yesterday, is the inverse of sine a function, your answer should have been no, because look at this. What test does sine fail? The horizontal line test, meaning his inverse is not a function. But we have, somehow our calculator is able to give us values. When we use inverse sine, it somehow pops out a value. This is why. The mathematical community has decided to start and stop the sine function on a certain domain. So it starts the sine function at negative pi over 2, and it stops the sine function at positive pi over 2. So it restricts the domain of the sine function, and it focuses on just this little piece here. We could easily create an inverse function of that. And I say we, and I mean somebody else, because it's not me. So what we're going to do next is you're going to watch me try to graph this, and we're going to think about everything we know about inverse functions. Well, this is what it's going to look like. We'll get there. On your paper, yes, on your notes, you should have this. All right, guys, it's time to have fun with graphing. First thing we're going to do is we're going to restrict our domain of our sine function. So just visually, you're going to basically cut it off from here to here, which this is negative pi over 2, and this is pi over 2. And this part right there is the only part of the sine function I want you to focus on. So over off to the side, what I need you to do is draw a new coordinate plane, and I need you to go back and think about inverse functions with me. There's really key properties to inverse functions. The main one was that the x's and y's swap and switch, so ordered pairs kind of flip-flop. That's interesting. We'll come back to that thought. But one of the other major attributes of inverse functions, their domain and range flip-flop. So if the range of sine goes from -1 to 1, that means the domain of arcsine, oh my gosh, that is not straight, goes from -1 to 1. So the domain becomes the range, and the range becomes the domain. So with that in mind, if the domain of sine is restricted from negative pi over 2 to pi over 2, that means the range of arcsine is going to go from negative pi over 2 to pi over 2. So at least I've given myself some boundaries. That should help, right? It's not going to help. This is going to get real bad. Okay, there's another attribute of inverses that we have to remember. They are reflections of the line over the line y equals x. You don't have to draw this on your paper, but just a little review, guys. When I gave you this graph last semester and I said I want you to draw a sketch of the inverse of this function, what you guys could have done was drawn the line y equals x, and then you would have, reflected it over that line, and that's how inverse functions appear when you graph them on the coordinate plane. So here we go. I'm supposed to take this and reflect it over the line y equals x, which is kind of like a diagonal line that goes through the origin. So here we go. Starts here, ends here, and kind of does, no, not that, kind of that. It should have had a little more curve to it, but you work with what you got. That's what arcsine looks like. So here's the key part of arcsine that we got to focus on today. Because of how they've decided to define sine's domain and restrict it, arcsine only exists between negative pi over 2 and pi over 2 as far as output values for range. So one of the first things that I'm going to need you to do on your unit circle is take your favorite marker color, highlighter color, whatever, and down at the bottom somewhere, I need you to either write arcsine, you could even say sine inverse, whatever, but use the color or highlight what you just wrote down in that color, and I need you to highlight where arcsine is going to be defined, and that is from negative pi over 2 to pi over 2. All right, we got to talk about something real quick. I know this is 0 radians. Pi over 6, pi over 4, pi over 3, blah, blah, blah. We already got those. But remember what we just said? It was defined from negative pi over 2 to pi over 2. So down here, what could you label this for radians? And you can't tell me 3 pi over 2. We're going to have to call it negative pi over 2. So on your little unit circle, could you please fill out negative pi over 2 down here? That's what you have to refer to that angle as today. So anybody have a thought about what we're going to call this? Negative pi over 3, very good. And then this guy is negative pi over 4, and then this guy is negative pi over 6. So that's kind of, in my opinion, one of the trickiest things today is to remember that when you move down to this particular component of the unit circle, when you're working with your arcsine, arccosine, arctangent, you have to make sure you're giving me a valid answer. You can never tell me it's like a value for arcsine is, oh my gosh, why can I not think of an answer all of a sudden? 11 pi over 6. That doesn't make sense for me because arcsine's not defined there. So while we're talking about just arcsine, let's go ahead and look at these questions. I do not think these are anywhere on your paper, so just watch. When it says arcsine of square root of 3 over 2, they want you to apply the arcsine feature. The place in math where this would have come up is when you would have been given this question. Sine of theta equals the square root of 3 over 2. Now think algebraically. What would you have done to this equation to solve for theta? You would have applied the arcsine or the inverse sine. So that's why they're writing it as arcsine square root of 3 over 2. So here's what you're supposed to do. You're going to ask yourself, where is sine equal to square root of 3 over 2? I don't know. Go find it if you don't remember. Look at your unit circle and tell me a place where arcsine is defined where the sine value is square root of 3 over 2. Pi over 3, I heard. Okay, very good. Exactly. That's all you're going to do. Okay. Let's look at this next question. So instead of using the word arcsine for an abbreviation, they used inverse sine, which we know is the thing we usually use. So eventually, or earlier, I should say, the question said sine theta equals negative 2 pi. That's weird. What's negative 2 pi? Some decimal, like negative 6.38-ish. Do I have the right decimal? I have the wrong decimal. I don't know. What's negative 2 times pi? I can't multiply today. The ice has frozen my brain. Well, 3.14 is 6.28. There we go. So this is asking me, where is your sine function going to give you a value of negative 6.28? Y'all, sine toggles between negative 1 and 1. Are you ever going to get to negative 6? No. So in this case, you're going to be like, no. You can say it's undefined. You can say it's not possible. Somehow you have to communicate to me that that is just not a problem you can do. You can't apply the arcsine to negative 2 pi. It'll give you an error message on your calculator as well. Assuming that you are in radian mode. So this next one, arcsine negative 1. So earlier the question said sine theta equals negative 1. So where is sine going to give you a value of negative 1? And this is probably the trickiest question on the slide. Say it again. Negative pi over 2. Very good. So a lot of kids say, Abruzzo, I said 3 pi over 2. You counted me wrong. Why do I have to count that wrong? Because it's not defined at 3 pi over 2. Sine is restricted, for this question, it's restricted from negative pi over 2 to pi over 2. So the only possible answers that you can give me are in between that interval. So I think that's probably the hardest question. And yes, I will put one of those on the test. All right, so good news. Inverse cosine. We get to draw that too. So they've already graphed cosine for us, but the mathematical community has decided that we will restrict the cosine from 0 radians to pi radians, and that's the only part of cosine that we will look at. So on your paper, could you figure out a way to restrict the domain on cosine from 0 to pi? And then everything that just happened on arcsine is going to happen on arccosine as well. So the domain and range will flip-flop, which means I'm supposed to graph it. Here we go. So the domain on the original cosine graph was 0 to pi. That means the range is now 0 to pi. I don't know why I'm putting a weird axis in the middle, but I did. Just, you're fine. That was stupid of me. My bad. Okay, 0 to pi. There we go. And then your domain, your range of cosine is now going to be the domain of arccosine. So instead of negative 1 to 1 for range, that is now my, oh gosh, here we go. My domain. Negative 1 to 1. All right, this is another fabulous moment for your teacher who can't graph anything. I'm supposed to figure out what the reflection of that looks like. It kind of sort of looks like that. Actually, that was pretty good. I'm going to go with it. Your textbook has really beautiful pictures of this. I am not going to ask you to graph arccosine, arcsine, or arctangent. So that's the good news. So what I noticed from this picture, just like with arcsine, arccosine is only in certain spots. It's stretching, the domain that is restricted to is from 0 to pi. So on your little unit circle, friend, let's go back here. I need you to use a different color, please. And I need you to mark up from 0 to pi. That is where arccosine is defined. So that one's actually not tricky, because you're not going to have any second guessing as far as like, oh, what do I call this angle? Like that question that Haley helped us out with, like negative pi over 2 was the only acceptable answer. Anything here from 0 to pi is going to be really obvious to you guys. Okay. All right, while we're at it, Looking at this picture, if you have a third color, you're going to need to mark up for arctangent. That's not arctan. Arctangent, I'll show you the picture real quick, but it is defined from negative pi over 2 to pi over 2, just like arcsine. So bad news, anytime you have an arctan, oh geez, anytime you have an arctan or an arcsine question, you got to be real careful about your angle because it goes from negative pi over 2 to pi over 2. That is the ugliest set of coloring I've ever done in my life. Okay. Real quick, guys, could you, while you have your notes out, can you draw yourself this picture on your notes? I am done trying to draw inverse functions today. So, inverse tangent, or arctan, has a range from negative pi over 2 to pi over 2. The domain, okay, this is a little confusing, because if you think about tangent, the range was undefined, right? So that means unrestricted, I should say. That means the domain for arctan is unrestricted as well. So technically this dude goes forever. So that's fun. Let's see what these questions look like. All right, on your notes, on the back, please. Can you believe we're almost out of time? This is crazy. All right. So have your little unit circle handy, and you got to make sure you're looking in the right spot. So this first question says arctan 0. If you want to think backwards, if you want to write a little note to yourself, this question used to say, when is tangent 0? Well, look at your unit circle, and please only look at the place. And I don't think are tangents on there? No, okay. Someone remind me, how do we find tangent? Sine over cosine. So you're looking for the one that would produce a 0 over 1 situation for sine over cosine. Who do you have? At pi over 2? I don't think so, because what's pi over 2's ordered pair? Yeah. It's 0, yeah. Okay. So if you ask yourself, when is tangent equal to 0, that's at 0 radians. Remember, 0 radians, the ordered pair is 1 comma 0, so that would be 0 over 1, which is why tangent's 0. Yeah, I mean, it would be really nice of me if I let you write all the tangent ratios on here, but I'm not going to, so please don't. All right, number 2. Arcsine square root of 3 over 2. So this question used to say, where is your sine value a square root of 3 over 2, but you're only allowed to look in the place where arcsine is defined. I heard pi over 3, I agree. Do you guys see that on your unit circle? Good, good. Okay. Arc cosine square root of 2 over 2. So this question used to say, where is the cosine equal to square root of 2 over 2? Only look in the places where cosine is defined, or arc cosine is defined. Is it pi over 4? Awesome. Okay, arctan negative 1. This question used to say, where is tangent going to produce a, where is tangent negative 1? Only look in the places where tangent is defined, and also the way I define them. Very good. Negative pi over 4. Because look at the ordered pair at negative pi over 4. It's square root of 2 over 2, comma, negative square root of 2 over 2. So if you did sine over cosine, they would reduce to a negative 1. Okay. And did you notice how she told me negative pi over 4 and not 7 pi over 4? 7 pi over 4 would be incorrect because arctan is not defined at 7 pi over 4. I know that's really confusing because you're like, but it's the same spot. It's technically not. Okay, because of the definition for the function. All right. Try a few more. I know you feel like we are almost out of time, but I don't have to get through many more examples. I just have to get to number 10, and then everything else in the lesson is probably going to be tomorrow, Friday's lesson. So. All right, so arcsine of negative square root of 3 over 2. So if you want to rewrite what this question used to look like, it used to look like this. Where is sine a negative square root of 3 over 2? But you better be looking in the right spot and call it the right name. Good. Negative pi over 3. Where, notice there's a lot of sines and tangents on here, right? Because those are the tricky ones. Where is sine negative 1/2? But make sure you're looking in the right place and you're giving it the right name. All right, no idea if I inserted this video properly, but on my old video, I'm about to really mess up number 7. So number 7 is supposed to be a trick question, and it was so tricky that it tricked me. So it says the tangent at negative 3 pi over 2. In my little pea brain during third hour, I thought it said inverse tangent, and I was just going with it. But this is actually an old question. This is like a question that we saw on our last test. So that was my bad. Literally, you're just finding the tangent at negative 3 pi over 2. So on our old test, we would be adding a rotation of 2 pi to find a coterminal. So what we're really calculating is the tangent at pi over 2. And then the tangent at pi over 2, remember tangent is sine over cosine. Well, this ordered pair is 0, 1, huh? So 1 divided by 0 means that you have an undefined value. So that was a bit of a sneaky, stinky little question. I'm going to attempt to insert this little blurb into my video, which means you're going to have to like ignore my stupid rambling for the next 40 seconds. And sorry if I just messed up the whole video. All right. Good. Negative pi over 6. Very good. Okay. That's not what the question's saying. That's a very tricky question. Here. Arctan, negative square root of 3 over 3. Okay. So this question used to say, where is the tangent negative square root of 3 over 3? So this one, I think, we know what quadrant we're in. So let's go ahead and look at that part of the unit circle. Please don't write on your unit circle, but we know it's going to be one of these, right? So if this was a test question, I know you guys are well enough to know that some of you are probably just going to type this in your calculator and you're going to figure out which one it is. And I understand that, but let me show you how to do it without a calculator because there might be a time in your life where you need this. Remind me how I find tangent? Sine over cosine. So like this dude, his sine over cosine would be sine times the reciprocal of cosine. And then when you rationalize that one, what ratio is it going to give you? Negative square root of 3 over 3. I already forgot what the question was. Was that the one I wanted? Oh, good. We found it. What was that? Negative pi over 6. Thank you for calling it the right name. All right, this next question is saying, where is cosine a negative 1/2? Cosine's not the tricky one, so don't overthink it. Where is cosine in the defined value? Where is cosine a negative 1/2? Just make sure you're looking in the right spot. Good. 2 pi over 3. Because remember, cosine is the one that's only defined between 0 and pi. You can't look anywhere else but 0 and pi. All right, and then number 10 here, we have the question about when is sine a negative 2? It's not, because doesn't sine wiggle between negative 1 and 1 for range? So this is another one where you can say it's undefined. You can say it does not exist. My friends who like to abbreviate things, I write a lot of DNEs on this homework. Okay, so you guys are assigned. Yeah, I know. Isn't that crazy? Well, you do have a few minutes. Calm down. Calm down. See, it's hardly enough time to learn any pre-calc. Y'all, the old homework check had the actual assignment on it. Can I steal yours, Oriana? Yeah. Okay. So it is bookwork. It's really short because these questions are just like a look and say, look and say, look and say. So page 288, numbers 5, and this is on Google Classroom, 5, 6, 8, 11, 13, 14, 29, 30, 35, and 36. So make sure you have that unit circle handy when you're doing that bookwork. Yes, I posted the key. Please don't be a silly pants who just copies the key, because these are hard if you don't practice them. This will not be on your test that's coming up tomorrow, clearly. This will be on the next test, but we'll worry about that at another date. So, test tomorrow on the old stuff. And then on Friday, we're going to finish this lesson. Got it?